because people not really coming back after the break. So it's just a typical thing. So we always saying that when you have a 15-minute break, it's become half an hour. Half an hour become 1 hour or something like that. So but eventually we have to start to keep on the schedule. So the Dr. Pagon, yes, the director of Space Agency of Thailand, or so-called JISDA, will give a talk and welcome the founder of JISDA here. Also, Dr. Suwit Vibun said here. So he's the one, the founder. So he's here also. So people will start coming back. But yes, please, Dr. Pagon, the floor is yours.
Right, thank you, Chai. This is the very first presentation of the year that I feel very excited because my first boss here, Dr. Suvit here, I want to make sure that I can put speak here. I think because of his support 20 years ago, I'm one of the, I would say, one of the legend of APAN in that time. I'm glad that APAN have a long life till now, like almost 20 years. Since then, I think we have developed a lot of collaboration and commitment to social. In fact, APAN is one of the good collaboration. It's converge not only space agencies but also networking to like IT, internet thing, the people to make use of the internet tool for data distribution and many areas. And today, I think this year, not today, this year, I like the what do you call the theme of APAN this year. You said empowering global network alliance for climate resilience. I think the climate issue is very important to everyone. This morning we have listened to at least three presentations from leading agencies in Asia about space technologies, and we can see that we all have activities in these areas. Climate change have become increasingly urgent, and they need innovative solutions, not only data, but also internet tool things, how to make use of our innovative technologies to transfer information to government, to people. This is really important. Like I said, I have been in this forum for almost 20 years. I'm glad that we see we are exchanging research topic, exchanging information about activities in our institutes, in our agencies. What we need is we have to step up from collaboration among agencies, among government agencies that Chai just said at the morning session. We have to extend our collaboration to not only government agencies, but also private sectors. We have to collaborate and converge technologies, not only space technologies, but we have to converge through other technologies. We have to step up to make sure that our information, our technologies can go to the people, can go to decision makers in the government. This is really important. The Earth observation satellite provide a comprehensive and global perspective of our planet. We are improving resolutions, better resolution, better frequencies, and even better accuracies of this observation. And now we can better monitoring and understand the impact of climate change. I think everyone understand that we have seen this experience, and everyone know that, especially you guys from remote sensing areas, you guys from information areas, you know that the ECV or essential climate variables can be derived from satellite informations. I think at least 60%. And we have, I think now our duty, our job, our responsibility to make sure that these variables can be used wisely. and to what do you call, to tackle with the problem about climate. I think we don't do only one factors, because remote sensing or space information can be applied for many areas in many, for example, urban and economics issues, water management, disaster management, agriculture, and other areas. Those factors or those areas are related to climate. Climate doesn't happen itself. Climate is occurs by human, probably not occur by human, occur by atmospheric change, occur by many parameters. When we want to tackle climate problems, we have to attack to work in various areas. This is very important, like, so we have to work with forestry, we have to work with water people, we have too many areas, so we can solve the problem at the same time in many areas. I think we want to learn that, but I want to again to echo the message to you guys on this. What we have done in Thailand, of course, we have research. We work with you guys. We work with many agencies internationally through many forums. For example, Central Asia's COS, GO, APAN, and many areas. But to work with those international collaboration, we have set asset. Last year we just launched TOS2. TOS2 is a high resolution satellite. We can capture the image red, green, blue, and also near infrared for 50 centimeters every 20 something days. But for every 2 days, we can get about the same area of the image, but different angle of the sensors. This can fill the gap. This can give you terrestrial information. Of course, TOS2 cannot do everything. To solve the problems, to attack the problem, to combat with the climate problems, we need several satellite types, several resolutions. That's why we need global collaboration. I think TOS can be one of the your constellations. I encourage this room to collaborate, to share information, to exchange information, technology, to make sure that we can tackle the problem together. From now, I want to show you what we have, our activities in Thailand. We have work with climate related issues or problems. This is the pictures of 2011 great flood. It's a long time ago, and of course this flood, not only the flood that we have in Thailand, we have flood every year, almost every year, not almost every year, but now we have El Nino this year or this 3 years. So it caused we have a drought this next 3 years, but not the flood is not the big problem now. What this picture convey? We have faced these problems 10 years ago, 15 years ago, and even longer than that. And we still face that problem. We still do research. We still claim to people that our technologies can help people, can help the countries, any countries, to solve the problem. Is it happen or occurs in real life? Is it actionable? Is it tangible? This is what we need. We have pilot project. We have research. How we can move up from research to operation. How we can promote the operation to the decision makers. Yeah. How can we deliver our information to people? I dream one day in couple years, people, my wife, my son, or your son, your family can use just mobile and say, oh, today we can have fun in our area next year, next 2 days. We have to move in these areas. We can have something and they can use in real life, real life. So with this collaboration among government agencies in our countries to work together, we need marketing people to echo our technologies. Otherwise, it can be difficult for us to ask for new satellites, ask for more research funding, research support from government, because politicians or anyone to decision makers, they need something proven in real life to show them. Forest fire monitoring is one other example that these are very active applications. Do what? Our prime ministers show people through Twitters that they use GISDA online mobile for forest fire monitoring. What we have done is we collaborate with government agencies. Of course, GISDA doesn't have our own satellite to monitor forest fire directly. Frankly speaking, we use NASA sensors, plus, of course, GISDA satellites and other people, our partner satellite from Europe and from Japan, and from many other countries. We combine, we integrate all information, and I try to, good opportunities to propose to decision makers and show them this is working, it's good. Now, Thailand, we have a mobile application for people to set up forest fire, not fire, set up a fire, not the fire for their land, yeah, for their land. Because the more, if you don't have good plan, good management, you're gonna get PM2.5, you're gonna get what do you call forest fire, or I think that would bad for your health. Some PM2.5 not developed by created by Thai people, but accidentally start from our neighboring countries. This is, we need evidence when we have government level to have a discussion with our neighboring countries to show them. I think we need collaboration. So this is another example that we make use for domestic use. Agriculture is one of the main applications that we have done in Thailand using satellite data. It's about 40% of our workforce in this country work for agriculture. So the monitoring system from satellite data can ensure up-to-date monitoring of Thailand economic crops, which includes rice, maize, sugarcane, and cassava. This system support many agencies, department within the Ministry of Agriculture. With great support from JAXA, we get update information for our Department of Agriculture. This afternoon at 5, we're gonna have meeting with decision making level in Department of Agriculture. They want to get update information. They want to make sure that they can make use of satellite data for the applications. But we also open to private sectors to join. We are also open to other technology developments, internet. It doesn't matter how good of your data is, but if you don't have good network, internet network, data cannot go too fastly or real time enough to people. So we need to go together to make sure that our data can transmit to people, to transmit to related departments. When you have agriculture, of course, you need very good planning for water management. Agriculture relies heavily on water usage. We have agriculture monitoring system being used and developed to provide water use efficiencies information. We have application called I forgot what the name is. แมงปอด้วย Dragonfly. That if you can search for Dragonfly, this application that our farmer use these days for watering their farms, their rice crop. We have rainfall information, which can tell them what is the nutrition, what do you call it, the ปุ๋ย เรียกว่าอะไรปุ๋ย fertilizer, sorry, fertilizers. What type of fertilizer can use for the rice cropping? We recommend them because this application is very good for these farmers. It's another example. In the ministry level, we have a like what DSS or decision making system, working closely with Department Ministry of Agriculture to provide agriculture's water efficiency platform using satellite data, satellite observations. This system allowed the whole information of the whole countries, as well as the summary of current situation, which include agricultural water demands, the availability of water supply, and efficiency index of agricultural water usage. This allowed stakeholders to understand the situation better. Satellite information, as you guys know, can track greenhouse gas emissions, deforestation, and urban expansions. We can help scientists and policymakers to make data-driven decisions and develop effective climate change mitigation strategies. We have a mobile app for users to get information about the carbon accounting 2 trees in Thailand for the country, and we update every 2 weeks for information. Those are applications. We integrate all those information to open geospatial platform called Sphere. And this is to open source and internationally standard. And this open source platform can give you all information that I just talked about, and open to all developers to try to test on to develop tools for especially country in Thailand, because this is like open data for Thai scientists. But if you are international, you are welcome. We're looking for developers from anywhere out of the world to develop some tools, for these areas. This Sphere just launched about a year. We have some developers to want to try to make use of the platform to make the mobile applications for users. And this for research. But if you go to commercial, of course we can talk about the business. But we encourage you guys to, if you want to get that open data, you want to get the open platform to make use of it, this is open for you guys. We also for the climate, we have the project called AIP, Actionable Intelligent Policy Platform for Climate Resilient Agriculture. Because the big data alone is not enough. We require to digest all of this data into intelligence actions. So we work with our stakeholders and develop the AIP for climate resilient agriculture. So with this tool, we wish that it can ensure data to be prepared with specific questions and analyze, so that it's ready for decision makers to take actions. So it's all for today. So just a short message. Want to exchange experience and ideas with Sky. So any questions, you're welcome. Thank you.
Any question from the floor? Any? No? Thank you. So next. Oh, it's from Singapore, the professor, Adrian, but Law Wing Guan. Yeah. Okay. He's a professor from National University of Singapore, Nanyang Technology University of Singapore, and then his topic gonna be talking about the assessment of the compound flooding through seamless linkage of coastal hydrodynamic and inland uh, catchment models.
Hi, good morning. So my name is Law, last name is Law. I have been with Nanyang Technological University for a long time, and recently I moved to National University of Singapore. So I come to the meeting first time as a student to learn what is possible with all the space technology and opportunity and partnership. And I came to be aware of the APAN because of my current involvement in one of the ASEAN center. I think for those, of course, I think we all familiar with ASEAN, but for those that comes from outside ASEAN, ASEAN is basically 10 countries coming together to explore partnership to improve the region. So under ASEAN, we have a committee actually driven by HII, started in 2019, called the ASEAN Hydroinformatic Data Center. And the intention is to work towards open data for disaster management, particularly related to flood management. And we hope to carry out research and also share knowledge about how we can mitigate disaster in a better manner, in a more collaborative manner in the region. So there are three main objectives under the center, which is technology matching. Basically, different countries have used different methods and different technology, and we can see how we can learn from each other through knowledge sharing. And then also along the way, we can involve more the young water expert in the ASEAN countries. And then with time, they can grow up to also become the leader. So in the future, we will have activity also related to AXC. And in the future, we also hope that you can join. So coming back again, because of this involvement in the AXC, and in fact, Singapore is currently chairing the AXC after Thailand has chaired it for 3 years. We are passing to Vietnam very soon. But because of this opportunity through AXC, I come to know a lot more about what is possible. And so this APAN meeting, I came to be aware of it, and I thought that I should come and just support and also learn. All right. And as a professor, and also I'm also involved in a center of excellence related to flood management in Singapore. I'm also working a lot with satellite images. Of course, I'm at the engineering level, and I just give you two examples. We use a lot of Sentinel-2 images to look at our coastal regions, our sediment plume, pollution dispersion, things like that, right? And just want to highlight that cloud cover has always been a problem in Singapore. Almost 80% of our satellite images with Sentinel-2 have cloud cover, interrupting some of the information. So recently, some of the technique using machine learning coupled with drones to basically using the GAN kind of GAN type of algorithm to try to guess beneath the cloud cover. That's what we have been also trying. All right, and there has been some success. Maybe in future meeting I can share some of the work with you. And on the right-hand side, of course, is the high-resolution SAR images that are available nowadays. I also came to be aware of them. In fact, if you look at the right-hand side, the images, it covers the southern part of Singapore coastal water. And the resolution is actually about 1 meter. But the only thing is, when I try to carry out research using the SAR images, I have been getting quotation of close to about maybe 20,000 baht per image, that type of expense, which I don't think it would be possible to make it something that can be widespread. So I think we also need to think about how to make these high resolution images to be more available. Sentinel-2 type, yes, it has been available, but now we do have this new generation of satellites, which offer much higher resolution. How can we make them to be more widely available? That would be something that I want to learn from you more. Now, but today, because I come for this meeting, I thought the least I can do is just offer some sharing, and so I have a very short presentation. Also taking hints from our previous speaker about yes, we can make all the observation, but we shouldn't stop there. We should continue to improve the technology so that we can actually make some real impact. So I start with this slide, and I'm from civil engineering, and I really feel for a long time that we need climate resilience infrastructure. Now, what do I mean by that? In civil engineering, what we often do is we have a historical data series. Then we assume a stationary environment. We do all the return period analysis. And then we go and design our structures, whether it's flood drainage or shore protection. But that kind of assumption no longer holds. The climate is changing on us. This whole assumption of a stationary environment, even a constant trend going forward, is not certain. It is very uncertain. So therefore, I think we have to develop really better and better modern capability so that we can perform expert assessment of what is happening, all right, on a constant basis. And we'll need to validate this type of assessment results also constantly using satellite and other new sensors, for example, drones and other sensors. I think this is the paradigm that we have to really get ourselves to be more and more used to. And so under this background, I actually collaborate with a company in Singapore called Suvarna Jurong. This company has a presence regionally. So we team up together and we try to improve the tool to look at compound flooding. So compound flooding essentially is due to the complex interactions among the inland flood and also the coastal processes. All right, so it's a combination of the two, and it's happening more and more often. Now, in Singapore, we are actually identifying it as a national priority. If you look at the left-hand side, basically, we're looking at sea level rise affecting our nation, and with the compounding effect of rainfall and sea level rise, we believe that the importance will be more significant. And if you also look at globally, this is actually a paper published in the United States. they look at the flooding situation around different major cities in the United States, San Francisco, San Diego, and so on. The dark band on the right-hand side, the dark band actually represents flooding driven by intense rainfall. As you can see over the years, the dark bands are the key driver for major flooding. But if you get towards the right-hand side after year 2000, then you get to the top right corner. And those are the flooding induced by compounding effect of storm surge together with rainfall. So I took a picture from the internet on the right-hand side. As you can see, when the sea level is already very high, and then if you have the rainfall coming in, then I think it worsens the situation. So the company actually support one of my research projects to try to develop tools to enhance the analysis of this compound effect. And essentially, we have already models on a catchment basis that we can look at flooding in inland. I don't need to go into it. There are many such models. In this case, I use the PC swim model, or swim model, but in general, is a big category of model that you can already use it very successfully to look at inland flooding. And on the coastal side, you have also the Mike model or the Del3D model that will also allow you to model the storm surge and so on. But I think it's the coupling of the two in order to analyze the compound flooding. That is difficult because a lot of times you do the inland, making some assumption of the sea, and then, or you do the sea, you make some assumption of the inland, and then you try to put the two together in some heuristic manner. So what we decided to do is actually go into a software platform, developing the Python script, basically to engineer so that we can now have a tool that can bring the two events together. And in fact, because of this is something I admire very much, is that the information from Thailand is openly available. There's a lot of information that we can actually get on a public basis. So in fact, we choose the Samak Wakang area as a test site to test out our Python script capability. So we use the one of the historical typhoon, I think it's the Typhoon Linda, to drive the coastal side. And then we also, based on some rain gauge, generate a 100-year storm on the inland side. And we're able to, on the coastal side, we're able to match the observed water level reasonably well. So this is the sea level going up and down with of course, the additional storm surge during the typhoon. And then this is the predicted induced flooding at that time. And we can actually even superimpose onto Google Streetscape to have a better visualization of the result. And then we also generate this 100-year storm and to predict the flooding. And we can do the same, impose the results on Google Streetscape. But what is, I think, what is interesting is this. All right. So with this capability now, I can generate the storm in any time that I want during a period. So I have this typhoon event that is in the background, and I can now basically, in a very simple manner, specify a storm happening at any time. And so therefore, I can do a continuous risk assessment basis, looking at the co-correlation of the two. So I'm not going to go into details, but you can look at, for example, in one of the situation, the timing of it, you can see that just the first column is due to the inland flooding. So you do have some flooding due to the 100-year event. And then the middle column is due to the storm surge. Now, when you add on the third one is the compounding effect. So it's definitely not just two adding together, as you can see. The high tide or the high sea level driven by the storm surge aggregate the flooding in a significant manner. So these are something that you can do now with this platform, and the company is using this capability now and carry out their urban planning assessment, resiliency assessment in the region. Right. So this is just a small thing that I want to just share with you in this meeting. So so just a small sharing, but I come more as a student and also a potential partner. Want to find out more how I can learn from you, and also what are the possibilities that are available. Right. So that's all. Yeah, thank you.
Now and go to the discussion. But any question to Adrian? No? Okay. Okay. Thank you very much. So the next speaker, Eric Yen from ASGC. He will talk about e-science. So you can talk for 1 hour because we have time left now. So I encourage to have a lot of questions if possible, so we can start the discussion and try to collaborate, which could be in more detail later in the working group session on Wednesday. We will have 3 separate working group sessions. We have agricultural, we have open and sharing, and we have disaster mitigation working group on Wednesday. The purpose is just like you have this masterclass for 2 days, and then we can have discussion on how to collaborate in the working group. It used to be like we give a talk, and then bye, see you next time. So perhaps, I don't know, changing that a bit to be like we can have time to discuss more and then try to collaborate that way. So that's why this is like coming up, like if we give presentation, just all given all together, and then during the working group we can just discuss how can we we have the idea before and how can we work together. Okay, the floor is yours, Eric.
Thank you. Thank you so much. My presentation today is actually try to promote the collaboration in the APAN community. So let me try to introducing some of the works we've been working on in the past few years in the disaster mitigation working group and also other working group in the APAN community. Based on the sustainable development things. I'm not the expert of this area, but I think everyone is aware of the crazy needs to achieve the sustainable development goals identified by the United Nations. A lot of things should be working on because to try to alleviate the increasing of the temperature, the increasing of the carbon dioxide. Based on the IPCC analysis, if we like to understand the drivers, the causes behind the hazard, behind those climate changes, we need to understand the some of the factors. Primary factor, for example, the exposure, the hazard, the vulnerability impacts. In the right-hand side, we can targeting on our local needs to understand how those factors is interacting with those targets. So in terms of the efforts, we can start it from the local needs. And then we can share our experiences and also our projects, and then we can work together so that we don't need to start everything from the scratch by everyone. So together we can move forward faster and better. So that's the values of the collaboration. That's also what we need, what we did in APAN, in the disaster mitigation working group. But for those efforts, the knowledge is the very essential, because we have to understand the physics behind all the hazards, so we can understand the impacts to understand the vulnerability and also understand the drivers. So in the next few slides, I will introduce some of the efforts we've been doing. From the United Nations, they keep monitoring in the country level, in the regional level of those according to the SDG goals. Here you can see the trends. Yeah. So for every partners here, we can also identify our indicators in our countries based on our local needs, as I mentioned. So you can see the this report from the UN. So, but to identify those problems is easy. But what should be what are the resolution? To identify the resolution is really difficult, because those SDGs are complex and intertwined, and it's highly complex in both spatial and temporal domain. Yeah, and also because we only have very limited knowledge to our Earth system. But fortunately, we can start it from the global indicator framework, as I mentioned in previous slides, already identified by the UN based on the Sustainable Development Goal. They already identified more than 200 indicators as a reference. In terms of the simulation or the analysis, there are also uncertainty issues. And most of the time, we do not have appropriate observation data when we need to do analysis or simulations. Luckily, we now have the many space agencies has been working on the sustainable development project, as mentioned in previous slides. Many agencies in Asia, we can work together in future meetings in Japan. So based on that, based on the advanced knowledge we get, then we can develop the simulation framework or simulation tools to build up the predictive analysis capabilities, either based on the physics-based approach or based on the machine learning approach. That's also will be useful. But the knowledge to the Earth system is still the solid ground to be available as we can. So the changes, continuous changes of the Earth, and also the anthropogenic factors are also another factors. The other thing is that most people like to answer the what if questions. So we need a simulation framework for this part. In the past few years, in the disaster mitigation working group, together with the agriculture and other working group in APAN, we've been built up in the left-hand side, based on the deeper understanding to those hazards. We developed some many about 20 case studies in different hazard types, and also build up the numerical simulation of hazards, those events happened in different Asia countries. So based on those selected case studies, we collect the observation data, such as the from the Doppler radar data of the hazard sites, Earth observation data, the ground observation data, etc. We have experts, the scientists leading the analysis of those hazards, and try to build up to improve the simulation model and also the simulation capabilities to reproduce the hazard happened. In next few slides, I will show you some of the cases we've been doing. And then after the analysis, we try to share those numerical simulation tools to be public. So all the Apan members could making use of the simulation tools to for other events in your country in different places. And so that's the cycle to improve the capability of the simulation. And the recently, there are the data intensive machine learning method has been one of the primary methodologies, such as the Google also developed the graph test, supporting the weather predictions based on the historical data. So in the future, the combination of these two types of approaches would be much helpful for the simulation and analysis, or even the predictions to support us to answer the what if questions, as I mentioned in previous slides. One of the very good reference here is the Destination Earth. That's one of the flagship initiative funded by European Commission, focusing for the sustainable future, which aims to developing a highly accurate digital model of the Earth on a global scale. So based on this simply speaking, that's a digital twin model of the Earth system based on the advanced knowledge, the knowledge we already have. And the system model is keep improved based on the knowledge, based on those observation data, based on those events we learned. So that's the interaction between the model development and also the real systems. So in the right-hand side, there is a framework, the logical architecture of the destination Earth systems. For example, the storage, of course, has to provide the how to access the data required by the user, how to keep preserving those observation data. All the system model is distributed, so the services could come in from each partners, not just in Europe, but also around the world. Of course, the system also should support the high performance analysis of the data intensive computing for different hazard types, to support the highly accurate and interactive and dynamic simulations, as mentioned. Currently, the primary development including the ECMWF, the ESA, and also meteorological agencies in Europe. And for further details, you can check the website of this project. In Asia, the first case is in Taiwan. We also developed the Taiwan Earth System Model. Earth System Model is a state-of-the-art tools for us to simulate the evolution changes of the Earth including the atmosphere, the land, the ocean, the cryosphere, etc. So that based on that, we can evaluate scientifically the impacts of the climate change. Yeah. So for the Taiwan Earth System model, we try to focus on the required spatial and temporal scales according to our needs in Taiwan. Of course, this model is also contribute to the global Earth System models. The other example is that the Typhoon Haiyan in Philippines. That's the first and also the primary case study in the disaster mitigation working group, because it's very difficult to simulate accurately for such a super typhoon, because it's really hard at that time before our study to reach the lowest pressure and also the strongest wind speed of such a super typhoon from the numerical models. So based on the analysis of this case, in this collaboration, scientists improved the simulation models so that we can rebuild the super typhoon life cycle from the birth in the Pacific Ocean until the impact of the storm surge impacting the Philippines. So the whole life cycle could be rebuilt based on the analysis through the computers. And in the long run, we can also monitoring the recovery and also the changes of the land use in the impact area, for example. Another case study is about the air quality forecast. That's also the project in AgWG, based on the academic research oriented projects. So the research group in AgWG, they developed the real-time and live prediction of the future 3 days air qualities around Taiwan, based on the observation data, based on the improved simulation models. So that's the long-term research objectives of the research group in AgWG. Try to identify the impacts, including the long-range duct transportation sources from, for example, the biomass burning in Indochina, in Southeast Asia, and also possible impacts to the East Asia in different countries, in different seasons. That's the long-term changes. So tomorrow, in the first session tomorrow, the second day of the Masterclass, the Professor Lin Chuanyao, one of the primary scientists, will explain details of these applications. In our collaborations in the disaster mitigation working group, we also have the scientist in UKM in Malaysia, Professor Liu. He is leading the group, conducting and supporting the flood hazard analysis. And here is the one of the case study in about the case in 2017 in Malaysia, which is the flood caused by extreme weathers in these regions. So in this case study, the model making use of the WIF, the weather forecast numerical models has been improved according to the Southeast Asia weather conditions, and try to improve the performance and also the resolution of the analysis outcomes, and also the incorporating the issues of the local topography complexities into such case studies. The other case that's about the ocean area, including the tsunami and also the storm surge. So several case study has been identified here. Left-hand side, that's the biomass burning, as I mentioned. In the center part, that's the about the tsunami caused by earthquake, also combined with the landslide after the earthquake in Palu, in Indonesia, in 2018. That's also very interesting, but quite complicated cases of a tsunami in this bay areas. In the right-hand side, lower right, that's the about the thunderstorm. We have some of the simulations and also predictions of the thunderstorm cases in Taiwan, but the requirements comes from Bangladesh. Sorry, because that causes a lot of life losses every year in that country. The problem is the data. If that's appropriate observation data of the weather, local weather data is available before conducting such analysis, supporting the predictions. Scientists also are able to predict the tsunami caused by the Honga Tonga volcano eruption in 2022, based on the same tsunami simulation models to simulate the tsunami wave propagation systems in almost real time, taking advantage of the high-performance data analysis. It's possible to simulate the tsunami wave propagation in less than 1 hour. So that's for a long distance settlements or populations, it's possible to do some kind of early warning for the tsunami case. Again, in the morning tomorrow, Professor Wu Zhuren, who is the expert in these areas, he will introduce the released parameterization model for the pressure wind field of typhoon around Taiwan, including those oceanic simulation things. As I mentioned, based on the tsunami simulation models, based on the experiences of the case study and also the collaboration with the scientists, into a web services. And from the website, from the URL, user could access the services by application of a user account. And with just 9 parameters of the earthquake, then you can get the tsunami simulation from the website according to the earthquake parameters. And here are some of the outcomes from the website for the typical case studies. You can see the wave height, the pictures of the simulations, etc. About the forest fire case, that's also part of our case studies, leading by Dr. Verchai here. And this is one of the projects conducted by Thailand, right? Funded by Asia Connect. Try to monitoring, collect the data monitored by sensors around the upper ASEAN regions. Try to And now we have we can move forward to take advantage of the Earth observation data from the satellite, from the support of the space agencies in different countries, to have better monitoring of the forest fire status, and also try to build up the predictions of the impacts of the forest fire in Southeast Asia. And in collaboration with seismologists in this region, from the earthquake scientists in Taiwan, we're supporting the deployment of the sensors, a smaller and a cheaper sensor for the earthquake, and collecting the data, and try to build up the warning systems in just seconds once the earthquake happened. And this seismologist also could, based on the Earth system model, supporting the almost near real-time moment tensor monitoring system, as in the right-hand side. It's also another online web services. Once there's any earthquake happened on Earth, then you can check the website and get the analysis data from the sensor sites. We've been learning a lot of applications based on the Earth observation data from space agencies in the morning. And this is the collaboration with the TASA in Taiwan. For example, the analysis of the land use and petty fields, and also the oil spill case around Philippines, the road traffic impact analysis after a landslide, and etc. In the future, I think we can have more better case studies based on the support from the Earth observation data. And on February 1st, Thursday morning, there will be a hands-on training sessions from TASA, making use of the Open Data Cube to utilize the Earth observation data for the applications. In the case study, we also have some of the application from with the Philippines, based on the efforts and also data from ASTI. Mainly for the, for example, the volcano and also disaster analysis, etc. So from all the raw data, observation data, or the analysis data, we need a way to manage the data. So from the research data management services, that could support easier access for the well-organized from the metadata to the raw data according to the applications. So in our framework, we have support from the scientists in academia Sinica. They developed the deposita system, which is very similar to the nodal system, for example. Supporting the, for example, spatial temporal search, the management of the metadata, the integration of the data source from CCAN, from the nodal, from other things through the web browser. And also, it's also possible to make use of the Jupyter so that the analysis or the applications using the data could be reproduced easier, just in your browser from your computer. It could also supporting the data management projects or research data projects, etc. So as a whole, here's a high-level logic architecture of the framework, very similar to the destination Earth. How to support the analysis or simulation or the data management. Yeah. Of course, from the user side, web-based services is the best way for user to make use of the services. Based on the local needs, you can work together with the scientists to build up the application cases. And then the new web services could be produced, could be generated based on such case studies. By providing the virtual research environment, for example, the simulation of the tsunami cases, and also supporting the machine learning enabled analysis with the Jupyter Lab, the machine learning framework, or through the command line interfaces, so that users could take advantage of the high performance computing powers from the underlying systems. What's important here is that those resources could be distributed. It's not limited to just the one supercomputing center, but you can submit your job to any computing centers, not just in the academic, but also from the commercial clouds are also possible. Through the research data management system, such as the depositor, you can organize your data in different systems around the internet. So one scenario is that you can make use of the Sentinel satellite data from Europe and finish your analysis in Taiwan. Or you can pull your data from the Amazon cloud and finish your analysis using the computing resources in NRI Japan, for example. On the other hand, in terms of the sustainable development, those computing service provider also has to take care of the energy saving issues in the data center, in the infrastructure. Yeah. Here are some of the experiences from the WSG. The first approach is that how to choose, how to make the decision for the trade-off between the performance and energy consumption. So the first thing is that, for example, if the ARM CPU is good enough to supporting the computing requirements of a computing project such as the WSG. So the group in UK, they evaluated the performance and also the power consumptions of different types of CPU. For example, the comparison between Intel and AMD, and also how the ARM CPU behaves in terms of the computing jobs. A short summary here is that in the recent 5 years, the power consumption by the computing servers decreased by 50% because of the evolution of the hardware technology. And the ARM CPU is much energy efficient than both Intel and AMD. And the improvement in the software and computing models also plays important roles for the long-term energy efficiency in order to cope with the evolution of the hardware. For the data center efficiency, that's our experiences, some of the prototype a project in our center in Taiwan. The first thing is that how to optimize the power consumption of the air handler system, the cooling systems in the data center. The second thing is that, of course, we have to collect all the data from the cooling machines, so that we can understand or to control the efficiency of the cooling systems. The second thing that we learned that the best way to save energy is to shut down the computer once the computer is idle. So you need a way to identify if there's how long is the jobs waiting in the queue? How many servers could I shut down in our computing infrastructures, and when to reboot the systems, and how many servers should be make available according to the jobs waiting in the queue. So based on our experience, it's possible to save 20% powers from the hardware, from the data center. So in summary, the adaptation to the sustainable development, or to the impacts of the weather or climate changes, there's no single approach to solve all the questions or problems. So we should start it from the local, from the needs of in your local sites, and then extend it to the national and regional levels. And in APAN, in the working group, and together we are building the capacity to supporting the numerical simulation, to supporting the deeper understanding of the target hazards. So the knowledge is a foundation to these parts, and also the collaboration with the scientists is very important, according to the physics based approach for the analysis. The other thing is that the persistent monitoring, either for the collection of the observation data or the efficiency of the approach we applied, is also essential. So in APAN, we are supporting the collaborations so that we can make changes little by little, by learn from each other, by learn from the needs in different partners. And we also have to keep on refine, and also to optimize the workflow from the monitoring, the warning, the review, and also the corrections of the whole process. Engagement of the local user community is very helpful in the collaborations. And together, based on the requirements from the applications and from the users, we can keep improve the analysis framework. And we need the to improve from on the computing, storage, and network, to improve the performance and also the energy consumptions of the infrastructures. So that's some of the reports, experiences from our side, and also from the collaborations. Yeah. Thank you. Yeah.
Any question? Yes.
Thank you, Eric San. Really interesting one. All these things, at the end of the day, it affects a lot on agriculture systems. Do you have any plan for including the agriculture also into these collaborations, which you are actually planning in the future? Yeah, thank you.
We need support from all the partners. It's not possible, for us to do everything. Yeah. So capacity building is very important. We hope, for example, in the future in your university, you can also focus on some of the topics you are interested or helpful in India, and then you can build up the services and also the systems, and then we can have such a system in different topics, in different targets, in different partners, and then we can federate together. We are not Europe. Yeah, we don't.
You're putting my words in my own mouth. Exactly. That's what we need to do it in future.
That's why we need the APEN, because we are not Europe. We don't have a commission to federate the resources. Yeah.
Thank you.
Yes.
Any further question or any? Oh, please.
Thank you very much. I think I echo a lot of what you say. And I think the data cube is very exciting development. I'm just wondering, let's say if I would like to get involved, how does it start? I mean, I'm sure there will be some resources we needed, right? What's the process like for somebody who wants to start to be involved in this data cube?
Yeah, we have data cube expert here in TASA. Yeah, we as a infrastructure provider, we are supporting the computing platform for the data cube. Yeah, in the future.
Okay, actually, we are going to promote this kind of technologies, and in TASA, we have kind of resources to do this kind of job, and we are very happy to share this kind of resource, not only technology, resource to everyone, and we hope everyone can join us and see what we can do for you. Yeah, go to. Yeah. But the first Thursday's masterclass. Yeah. maybe in that time we can discuss more. Yeah.
Sure, thanks.
Anything of internet too?
Yeah.
There's something new on that for application to the internet. No, it's good. Any further question or comments? That tomorrow we'll have more on the open science from no, sorry, I just mixed up again. This afternoon we'll have the open science from UNESCO. She couldn't be here because she's supposed to be here, but she got an accident, so she'll be online. So Dr. I from UNESCO. And then you have from Korea, Suzin is here. We'll talk about what the AgWG is doing for the 15 countries. And hopefully Jean-Michael Michel will be here from the France embassy in Singapore, but he's thinking he's going to be on the way like at noon. So talking about what the French government can do. But for now, I think if no further question, we can go for lunch and come back here at 1:30, isn't it?
Yes.
1:30 here. So yeah, thank you very much. Thank you, Eric.
Thank you.